Don't make me laugh.
Oh.
Hello, my name is Michael Weinstock. Everyone calls me Mike, and I'm here to talk to you about MTech. It's an MSc and MArch program, and you can see here the images in front of you. That's me looking very relaxed in the bath. It's a structured program that really has two phases. You'll be able to see these in more detail in a little while. And we start very quickly with boot camp in the first few days, where you're dealing with material systems. It's, as you can see in these next few images and little videos, you're learning both the geometries and how to make things and understand how to small physical components can interact to make larger, more complex organizations of material, and those that have actions which you can open and close, which is for performative skins and so forth. We do all kinds of physical experiments. All of our computation is calibrated from physical experimentation. But we're also exploring in these mesh relaxations, and some of the physical stuff is really fun. It doesn't always work, but we also learn how to fail better. So it's important that all of our failures are teaching us logics and processes for the assembly and performance of material systems. As you go through the program in the first term, in phase 1 and phase 2, you're exploring both geometries and fabrication technologies, various ways of producing surfaces and materials through digital fabrication. And you learn by hands-on. We have a new program in the last 2 years that we've added to that, which is robotics. Elif, who's our studio master, is our robotics guru. We've had 2 or 3 of the MArch dissertations exploring this, where people design the end effector. We're able to simulate and teach you how to simulate tool paths to explore continuous line processing. And this particular one came from a very nice MArch on using salt with a polymer to stabilize it. And the issue they're exploring is, of course, you have to heat it to make it have a structural consistency. So these are kind of experiments in the dissertation phase that you might be taking on and doing in your dissertation. It's a principal topic for us. We have 2 or 3 others, which I'm going to show you a little bit about. Robotics starts in the first term. We did some experiments, again led by Elif in the summer last year. And these are a series of stills. This is the end effector that was designed by the students and fabricated by them. In this particular dissertation, they're looking at both fast and slow prototyping. In the second course that we have that's embedded in the studio is biomimicry. And we work from analysis of natural systems. We're particularly interested in how we develop algorithms from the social behavior of insects, jellyfish and various other kinds of social organizations that appear in the natural world. These are kind of amazingly good sources for algorithmic processes. And we abstract knowledge from them, behaviors, and then we learn how to encode them, and we apply them to architectural surfaces, and we explore them as kind of growth models. Stigmergy, which is a really kind of nice biological word, a kind of fancy one you can look up, but it leads us to a series of repetitive actions which are extremely powerful, simple logics from which we can grow very complex things in a series of very simple steps. We have another way of imitating knowledge that we take from nature, which is my particular area of interest, which is from genetics and working on evolutionary computation. This is looking at the graphing functions, and we're looking at 4 different kinds of conflicting criteria that this design is evolving towards. And we can run up to 1,000 generations and keep track of every single individual in those generations. You learn that in the second term. It's a 2.5 to 3 week course. We start with a primitive. This is kind of example from previous year. So every student, before they get to the end of phase 1, is has knowledge and expertise in writing their own genetic algorithms. The major part of the second term is on design project, which is to do, we're located mainly in the marshes and wetlands for the next 2 years. You're part of a 3-year exploratory program on ecological urbanism. And by now you have kind of full set of skills and that you're able to apply to developing these more complex urban patterns, all of which have a behavior. And we're very interested in surface analysis, risk analysis of various kinds, and here you can see 5 different criteria again running simultaneously on this. So these are taken from the dissertation phase. People make up their own decisions on what their topic is, what their team is. We usually work in teams of 2, and you write your own, without help, write your own program and pursue your own interests for the dissertation. We also have been looking at the dynamics of urban systems in ecological situations, and these are more complex. And we're looking also at how we can make these productive. So city is not an isolated artifact with everything occurring outside it, but within the city itself, or the smaller cities, we're producing landscapes which are growing foods and things. We've been looking for a couple of years at AR, which we're now extending into VR. The first phases and the first dissertations, the principal use of AR explorations has been for assisting in the assembly and fabrication sequences of complex geometry architectures. So it's kind of one of the big issues in new kinds of architecture is the position in space of complex objects, and by using AR and keeping track of the positioning, this was an app developed by 2 students, which is now both of them working in high-end offices that are using these techniques for real sites. And you can see a little bit from their dissertation now, the assembly sequence. We like to build. Every year we make something, pretty big projects mostly. We get them sponsored, we raise the money for the materials, and it's part of our culture in MTech that every year we build some sort of pavilion or canopy. This is one of my favorites some time ago. And we start in studio again with fairly simple experiments. Everybody participates, everybody finds a role. Our job is just to keep you more or less on track, where we're not telling the group themselves evolve who does what. And we have developed, I think, some very significant and large-scale timber structures. This year and the coming year, we're working with sheet metal and robotics as part of Elif's innovations for us, which I showed you at the beginning. And we're working on sheet metal formation with robotics. But these are the kinds of scales that we'll be dealing with. We did kind of slightly primitive try a couple of years ago. This is Fingers Crossed, which was in the Arab foyer for over a month. This is at the National Building Centre in Birmingham, the exhibition. And you can see part of the computational logic that goes into making it. This is the year just completed, and Maria, who's sitting near me, will maybe talk a little bit at the end about this. They helped to make this, but they also made a virtual reality app that people could see it in the exhibition. This is the exhibition, one corner of it, and this is the other corner, and you can just about see, I think, people behind there. So, and now I'm going to introduce you to 2 people who are currently at MTech, and the first is Neal.
Hi everyone, I'm Neal. I'm excited and honored to be here today and to be talking to you guys. Just a little bit about me. I grew up in a small town outside of New York, and my background is in chemistry and architecture, which is actually one of the reasons why I decided to come here to MTech, because it really was able to sort of merge sort of the science methodology and sort of this architectural background that I had. I just wanted to show you a little bit about my work today. see here.
Can we go back one?
Yeah.
Okay. That's Neal in the middle there.
Yeah, that's me.
Okay. Everybody's surrounding Neal and pointing at him.
So this is one of our first projects here at MTech. I worked with a dear friend, Tim Fu, and basically our aim was to take a base trigrid surface and manipulate it and control it in a way to create a doubly curved surface. So we started out with folding techniques, and eventually we created a lock and key mechanisms that were derived from mathematical functions. And so we were really interested in how we can combine these functions to create these doubly curved surfaces. And as you can see, at MTech, it's really about the iterative process. We were really impressed with the fact that we were just able to manipulate just certain keys and just put them together, and we were able to create so many different types of surfaces out of them. The weaver ant. Yes, this is my favorite. This is part of the natural systems and biomimetic seminar here. We specifically studied the African weaver ant and sort of other eusocial insects as well. And we abstracted their behavior. We noticed that there was like an innate algorithm that these eusocial communities sort of operated on. And so we looked at nest construction, and we looked at food recruitment strategies. And the goal of our project was to create a shell structure. And we did this by using an agent-based system where we first constructed an environment. So in this case, just a surface. We performed a structural analysis on that surface, and then abstracted a certain amount of attractors and repellers in the environment. Also, sort of these stress nodes, essentially, that we were able to get from the structural analysis itself. And we found how the agents would sort of move between these paths. And then we synthesized those paths, and then we're able to create a shell structure out of it. Our big goal, though, was to take those structures that we created and perform a structural analysis on that once again, so that we could actually see the physical properties of it and if it would withhold in the general context of the environment. We don't always work here. We love to have fun too. So this was actually a really fun project that we worked in conjunction with the Digital Prototyping Lab. It's open to all AA students here. And we were able to program robots and essentially dance with them and create these light images in three-dimensional space, which was a lot of fun. And here at MTech, it's really about the family. We have a lot of bonds. We love working in the studio together. We work very long hours, but it's so much fun, and it's just a great place to be with so many international people from all over the place. We're always eating new food and talking about everything. So it's great. It's really, really great. And yeah, I'd like to sort of move on. And this is my good friend here, Maria. She's 1 year ahead of me. She's phase 2.
Yes. Well, so I'm Maria. I'm an architect who graduated in Seville years ago, and came to London, started working and pursuing my aims, my goals of being more, learning more about computational design and making. I decided to join MTech. And well, as Neal has mentioned, in MTech you will meet a lot of people from all over the world, and with these people you will share, apart from background, common interests. Interests that will be reflected in your groups, the groups that you are going to form in the studio. So here I'm going to talk about the group that I immersed now, which is my dissertation team. And with these 4 girls, Leana, Maria Cristina, and Carolina, we developed our dissertation, Urban Glitch. Okay, so our common interest was participatory design, which is a design method where users of a place, of a neighborhood, for example, get involved in the design process. So what we proposed was a different approach of participatory design using immersive technologies. Immersive technologies, I refer to virtual reality and gaming. So here you can see a video of one of our experiments in a public workshop that we did on site. And basically, people got very involved in the process and help us develop the work. So one of the first challenges that we faced in our dissertation was to build the application that we were proposing as a design tool. And given that we are proposing a virtual environment, we wanted it to be totally immersive, that people could really live it. So the first challenge was to transform this into this, which is it's an image of our game. A game that you are able to play using cubes. So we propose using 3D scanning. An interesting part of it is that we use photogrammetric 3D scanning. Basically, we gathered up to 500 photos on site. It was quite good work from our side. We developed then the mesh with these photos using a specific software, and eventually you were able to see the mesh totally formed with these maps and shapes. Of course, I have to say that it needed a lot of refinement, but it's a good outcome. So in MTech, one of the most important aspects is that you do a lot of experimentation. And for example, here you can see us in the class testing the virtual reality headsets. And for example, for the final experiments of our dissertation, this public workshop, we carried out up to 30 mini experiments before jumping into the big one. And in this last experiment, we achieved a high number of participation. And the results were all combined in this computer application that we analyzed and extracted the data that was going to be given to architects, and that we invited via social media to participate in designing their own proposals. So like that, we wanted to really narrow the space between architect and user to obtain a final design that better adapts to their preferences. And I would like to finish by saying that in the dissertation you are going to spend most of the time in MTech, and it's vital the hard working group, but also tutorials in class are very important. And specifically in this project, we did a lot of research and self-learning about gaming, and it was very productive in order to achieve a good work at the end. Thank you.
Okay, we have some questions to answer, but I'll just say a few more words. MTech's a science-based studio. We have a lot of fun, and we kind of really want people to come who love their work. And we enjoy it, and I think you've seen from these guys, we can do great work and enjoy ourselves, and we enjoy the building as well. Neal's been with us 10 weeks, and you've been with us a little more than 1 year.
Yes.
And that's a kind of trajectory from kind of great excitement at the beginning to around about April or May, you start to get your serious questions, and then you spend, as you have done, the second half of your time several months working very intensely as a research design projects. So the people you can't see, the lovely Imogen and Kirsty, who you probably know digitally if you apply, because they will be handling all the things, are going to feed me with some questions and stuff. The last thing maybe to emphasize as we're collecting the questions is the culture of the book. We do intense computational work, and science and data and numbers are very important for us. but we produce at the end what we think of as the beautiful book. And I think this is a very architectural synthesis where you can bring science to these things. So we will show a little bit of those maybe more at the end, and someone is about to pass me some questions. Thank you. Okay. Okay, so the first question is, what's the difference between the MSc and the MArch? And maybe I'll answer that because you are both MArchs, right?
Yes.
Okay, so first of all, there's a difference in time. There's a little difference in money, and one term's difference, which can be significant. So sometimes people who are architects do choose to do the MSc because they can't quite afford the MArch. But you sit next to each other in the studio, there's no difference in the work you do. And the team, some of the projects, in your case, the projects that you showed, were
2 MSc.
2 and 2 MArchs and 2 MScs.
Yes.
So we do have work that continues right through and it's simultaneous. If you have a Bachelor of Science, you can do an MSc. If you have a Bachelor of Architecture, you do an MArch. And there are people like Neal who have Bachelor of Science in Architecture. There's no such thing as a Bachelor of Architecture in Science, but maybe there should be. So we have people from all kinds of backgrounds. I think yours is chemistry. We have people before who've been marine designers and builders, and we've had jewelers. The majority are architects, but I like to, as far as I can, make a very mixed studio. And I came here, I don't know, a long time ago, 35 years ago, and I've stayed because everybody is from somewhere else, and we're always bringing new topics, new subjects, new cultures. Second question, the career path. Which professional career path do most graduates go on to work in? And maybe you'd like to say where you would like to go, and maybe you afterwards would say kind of what you would like to be doing.
Yeah, definitely.
Because I'm closer to finish. About to start my portfolio. I think given all that you learn in MTech and all the qualifications that you gain, there are very different paths to follow. In my case, I would like to dedicate part of my future working in research, very related to what I'm really doing now, because I really liked it, the virtual reality field and new technologies. And of course, the work in a big company will be ideal. I really like to work in a multidisciplinary team from which I could even learn more. So, yes.
That's awesome. I mean, I would love to teach one day. I mean, that would be the most amazing thing.
He's born to be a professor.
No, I mean, it's just something about the academia environment that is just so free and motivating and inspiring, and especially in architecture, because it really gives us like a leeway to just talk about anything and everything, really. And this, like, compared to other, realms, and I just would love to be in school forever.
Okay. Well, I have been, I think, and I'm not finished yet. So, Elif and I are just putting together a kind of research grant application, which, if we get it, we'll be pursuing robotics and artificial intelligence for the next 5 years. So, that's the delight of academia.
Yeah.
It's got its downsides. It's not all fun. We have any more questions? Do we have? They're saying no, and somebody's thinking about how we could kind of finish up this, because we only have a couple of minutes left. When you come to MTech, if you're considering applying to us, you can write to me, you can email me directly, or Elif is our studio master. We'll be able to answer some of your questions about content, topics, how to prepare, and so forth. The school, Imogen and Kirsty in the admissions office will help you with procedural questions of qualifications, how to fill in the forms, kind of online applications. We know most people who come from far away, and it's not practical for you to come, all of you to come to London to talk to us, although Neal did, from New York. But we can do Skype, and we can have other ways of having conversations with you to explore if you'd like to know more things. We have a lot of online data. We also have our own Facebook, and I have a personal one, and you can find those online. And we have a school microsite which has some of our built projects and some details of teaching, and has the student guide handbook. And somebody's waving, so maybe we should all be thinking about waving goodbye. So I really, really hope we can see you in school in MTech soon. Thank you.